Hi, once again, this is Mr. Wakefield coming back to you once again for the last section of Chapter 3 and also the last section of our current worksheet packet, which just consists of Chapter 3 this time. Talking about two different things today, varies directly and varies inversely. There's also some different combinations of that we'll talk about as well coming down here. But these are the two main ones, all right, that we talk about. Varies directly, which is otherwise known as, sometimes you'll hear them say, directly proportional. You'll hear that phrase. That's the same thing. It's the same as saying that it's directly proportional. So, for example, if they say y varies directly as x, y varies directly as x, that's the same thing as saying y is directly proportional to x. Y is directly proportional to x, okay? In the same way, when you see varies inversely, that's the same thing as y is inversely proportional to x. And you may have heard that phrase before, and if you haven't, that's okay. But when somebody says that y is inversely proportional to x, they're saying that as y gets bigger, x gets smaller. It's in an inverse direction. As one thing gets bigger, y, the other thing, x, gets smaller, and vice versa as well. As y gets bigger, I think I said that backwards. Sorry. As y gets smaller, the x then would get bigger. So the y and x are always going in opposite direction when it's inversely proportional or varies inversely. Same thing. Okay. Here's an example of that here. Length times width. All right. Just to let you know what these letters mean. Length times width. The area of a rectangle. Okay. If you divided both sides of the equation by L, all right, which you don't need to worry about all that right now, but I'm just saying that this is what we would end up with. This means that the width and the length are they're inversely proportional to each other. Let me show you what I mean. If I plugged in 10 right there, that's an L, not a 1. That's an L. If I plug 10 into that L right there, it would be equal to 4, wouldn't it? L equal to 10 would give me W equal to 4, wouldn't it? Okay, but if I plugged in, say, L equal to 8, the W would actually get bigger, wouldn't it? It would become 5. See what happened there? L decreased from 10 to 8, and at the same time, W increased from 4 to 5. That's what inversely proportional is basically about. There's more to it than that, but that's one of the key things, is that as one of the variables gets bigger, the other one gets smaller. All right. Direct variation, which is that there's an example of that up here as well. I'll show you that in a minute. But directly proportional means that the y and the x, as one gets bigger, the other one does the same thing. As one gets smaller, again, the other one does the same thing. All right, so here's a prime example of that here. It talks about if you're driving at a constant speed, say you've got your car on cruise control, for example, okay, and that speed is 60 miles per hour. Then the distance that you travel, which is d, and the time that it takes to travel that distance, which is t, would then be directly proportional. That means that as t gets bigger, d gets bigger. All right, so what if I plugged in t equal to 2 right here? All right, I would get 120, wouldn't I, for d? But if I plugged in a bigger number like t equal to 3, say 3 hours, all right, for t, if I plug that in, the d would become 180. All right, so as the t gets bigger, the d gets bigger as well. It goes from 120 to 180. That's direct variation, all right? Direct variation, directly proportional. Again, that all means the same thing. All right, as one gets bigger, the other gets bigger. All right, in this case, d and t, those two variables are directly proportional to each other. They vary directly as each other. All right, so that's the difference between these two. So let's go ahead and try that concept out down here. All right. In problem number 1, it says if y varies directly as x squared. Let's talk about that. If you take that concept, all right, and you, I'm just going to put the top of the page here right next to it at the same time. It says y varies directly as x squared. Let's actually take that and rewrite it here. Y is still the same. And then it says y varies directly as x squared. So now the x squared is right here. Instead of x, it's now x squared. Okay, what does the formula tell us to do here? It says that whatever the thing is that is before the words varies directly, whatever that is, see how it says y right here? And now there's a y there. So they're telling you that whatever goes before those words varies directly, they would go before the equal sign. And then you put your equal sign. So like, for example, if this had been a T right here, the letter T, then you'd put a T right here before the equal sign. Whatever goes before the words varies directly, that goes here. All right, and then what you do is the K is a constant. That's always going to be there, okay? And in fact, they call it a constant value K. But then look at what happens here. It says as X, right? And so sure enough, the X is right after the K. But in the actual problem that we're doing right now, it does not say as X. It says as X squared. See that? As X squared. So whatever goes after the words varies directly as, which would be X squared in this case, that then, just like the X did right here, all right, that then would go after. Okay, let me get a little bit colorful on you here now. So what they're saying is that this thing right here, I'll put it in green. That thing right there goes here. Okay, green here, green here. All right, whatever this thing is right here, I'll make that blue. All right, pardon me if you can't see that very well. I know the colors kind of get a little bit dark there. But green for Y right here. This is blue, and so that would go here. All right, so my point is the reason why I'm using the colors is that whatever goes in this spot goes in this spot, green and green. Whatever goes in that spot right there goes in this spot here, no matter what it is. It doesn't have to be X. In this case, it was X squared, but whatever it is, it goes into that spot after the K. All right, so our equation in this specific problem, let me write that down, is going to be y equal to kx squared. Y equal to kx squared. That is your first step on any of these problems where they talk about variation, varies directly, varies inversely, directly proportional, inversely proportional, any of that stuff. Okay, that's always your first step, is establishing what your formula is. Okay, the second step is always going to be figuring out what that k is. And I'll tell you why that's important here after we do it. But the second step is figuring out what the k is. All right, remember they said it's a constant number. We just don't know what it is yet, and that's why we called it k. All right, the way you figure that out is take a look at this phrase right here. See how it says that y is equal to 9 when x is equal to 5? That word when is very important there. Whenever they say that one variable is equal to 9 when the other variable is equal to 5, what they're saying is that if you plug both of those numbers into x and y right now, into your formula, the formula will be true. Okay, it will be it'll actually be equal. Okay, it'll be a true statement. The equal sign will be true. And so let's do that right now. Let's plug in the y equal to 9. I'm just plugging it right into there. Y equal to 9 equal to k times, and I'm going to plug in the 5 right there. Use your parenthesis. I didn't need the parenthesis over there because 9 was all we had. Okay. You could put a parenthesis there, but it's just going to be the same thing. If the parenthesis is all you have on that side of an equal sign, it's not needed, although it's not wrong to put it there. But then now that I've plugged in those two numbers, this is true. And so it is truly equal. And so if I solve for k, if I get k by itself, I can then truly say that that's what k is really equal to. Okay, anytime you plug in a number into a normal term, all right, like a normal monomial term like we talked about all semester, you want to simplify that first before you solve the equation. And we have to do exponents before multiplication. So 5 squared is 25. And then what's k times 25? K times 25, of course, is 25k, right? So once you simplify that term, it then looks like a normal equation now. And so we go ahead and solve that equation, and we know that this is a normal linear equation. It's k to the first power. There's no k to the second or anything. So we need to divide out to get the k by itself, and we get k equal to 9/25. Now, it's okay to make that into a decimal if you want. You don't have to. If you're going to keep a fraction answer, and this is not the final answer anyway, so you could keep it as a fraction, but you need to, you could make it into a decimal if you want. Just to make it a little bit easier, I'm going to make it into a decimal. Do not make it into a decimal, though, if you have to round off the decimal, or if it's one of those big decimals that covers your entire screen on your calculator. Okay, because that usually means that the calculator rounded it off. So, but it's not like that. If I put 9 divided by 25 into my calculator, it is exactly equal to 0.36. So you could either use 0.36 as your K number, or you could use 9/25 as your K number. I don't mind. All right. Now that you know what K is, look at this here. It says here, find Y when X is equal to 20. All right, well, if they want you to figure out what one variable is and they give you what the other variable is equal to, that means, and we saw this when we were graphing lines and graphing parabolas and different shapes and stuff back in chapter 2 and even at the beginning of this chapter. If you want to know what one variable is equal to when you already know what the other variable is equal to, you plug that 20 into the equation, the formula equation, same thing, because it has an equal sign. But you plug that in, and it will then tell you what the y is. All right. And so if I do that, we can also plug in the k now, because we now know what it is equal to. We didn't know what it was equal to over here, so that's the reason why I didn't plug in the 20 yet. Okay, if I plugged in the 20 before figuring out what k was, then I would have ended up with k times 20 squared. Well, that ain't going to get me anywhere because I didn't know what k was. Now that I know what k was, I can now do it. I have y equal to, and then I plug in the 0.36 right here. Just bring that up in there. And then plug in the 20 where the x is. Again, I'm plugging this into this formula here, okay? So what is this going to be? It's going to be 0.36 times 20 squared. Remember, exponents come first before multiplication. And so we get 0.36 times 400. Okay. If you put that in your calculator right now, that will be equal to 144. 144. And so we did it. We figured out what y was equal to when x was equal to 20. Not a surprise, by the way, that notice that when x was equal to 5, y was only equal to 9. But when x got bigger, it went from 5 to 20. Not a surprise that y also got bigger because it was direct variation. It should be doing the same thing, y and x. Okay. Now let's talk about inverse variation. But the process, you guys, is the same. Okay. You always, in any variation problem, okay, in any of the problems in this section, you first of all establish what your formula is. The second step is always to figure out the k number, because that's always going to get in your way of finding the answer. And then after that, you answer the final question that they have here at the end of the problem. So y varies inversely as x. All right. What does that mean again? Y varies inversely as x. It's just the same as it is right here. You don't even have to do anything different. Now, like up here where we changed x to x squared, you don't even need to do that here. But the point is that whatever goes here, let's put it in green again. Whatever goes there, even if it's not y, okay, it would go here. So if that is, say that was M right there, the letter M. Okay, if M is there, then M would go here. All right, and then whatever goes after the words varies inversely as, okay, even if it's not X, whatever it is, okay, that will always go here. Notice though, again, that it's division this time. Okay, it's K divided by that thing. All right, so if there had been a T right here, the letter T, then it would be K divided by T, not K times T like it was up here with the direct variation. So that's the big difference. Direct variation, you multiply by the second thing, okay? Inverse variation, you divide by the second thing here. The thing that's after the varies inversely as, you divide by that, okay? So let's try that here. All right, our formula once again is y equal to k divided by x. Again, if this had been direct variation, if this had said varies directly, then it would be k times x. But because it says inversely, divide. All right. Step 2 is always going to be figuring out what k is. All right. In fact, I'll write that down up here. Find k. Find k. All right. And what we do is we take the statement where they tell you what both x and y are equal to together. And I say together because that word when is telling us that 20 and 1/4 are both true at the same time. Y is equal to 20 at the same time as x is equal to 1/4. They're both true at the same time. When they give you a statement like that, it's usually going to be in the middle of your problem somewhere. Okay, when one variable is equal to something at the same time when the other one is equal to 1/4, then you plug both of those things into your formula simultaneously, and that will allow you to figure out what k is. Sorry, I didn't do that there. I wrote y again for some reason. I wasn't thinking there, sorry. So there we go. So we're going to replace the y with 20 right there. I'm just using the same formula. Okay, I replace the y with 20 as this statement tells me to do, and then I put my k. And then I got to plug in 1/4 underneath that. Okay, that looks kind of weird, huh? There's a lot of different ways you can handle this. Normally, when you have a fraction, as we saw a lot in the last section especially, when you have a fraction on one side and just a normal term on the other side, you can cross multiply. Okay, but 1/4 is a fraction in itself. All right, we got a big fraction. This is one big fraction right here, and then we got a little fraction underneath that big fraction. All right, so what we do is we multiply 20 times 1/4 and k times 1. We cross multiply, just like we always do when we have a single fraction on each side, and that's it. Okay, so k times 1 is k, but what is 20 times 1/4? All right, that is 20 over 1 times 1 over 4. Anytime you multiply a regular number, 20, it's not a fraction, times a fraction, you make the 20 into a fraction so you can multiply by the other fraction. And as we know now, that's going to be equal to 20/4, which is 5, isn't it? And so that means that k is equal to 5. All right? So now we know what our k is. Just like in the last problem, you guys. Establish your formula, figure out what k is, because that's always going to be the thing that gets in your way, is the fact that you don't know what k is yet until the second step. Then once you do know what k is, and you're done with the second step, the final step is to then take this final question that they asked us, which is find y when x is equal to 15. Now that you know what k is, you can plug that in over here along with the 15 that they want us to plug in to figure out what y value goes with the 15. Okay, you plug that in also along with the k, and it gives you what? Again, I'm using the original formula again here. I'm plugging in k equal to 5, bringing that up here, and then I'm plugging in x equal to 15 because they told me to, and y is actually already by itself, so we're pretty much done. We don't need to get y by itself like we did. Actually, in the last problem, it was by itself too. But if it's not by itself, you get it by itself. Since it is already by itself, you just figure out what 5/15 is equal to. Again, you can keep that as a fraction. Unless I tell you otherwise, you can keep that as a fraction as your answer as long as it's in lowest terms. Okay. If I ask you to make it into a decimal, if I say to round it off to the nearest tenth or hundredth or something, which also means to make it into a decimal, that would be a different story. We'll see that coming up here. But otherwise, you can leave it as a fraction. Just put it in lowest terms. And as you guys know, 5/15, if you reduce that to lowest terms, is 1/3. And so that is inverse variation, you guys. Okay, now, as we move on further to number 3 here, we start to get into some actual word problems here. And so we got to be a little bit more careful, obviously, that we understand what we're reading here. All right, so we'll go through it carefully. But it says the volume of a right circular cylinder. By the way, a right circular cylinder, if you want to just get a picture of it in your mind, it's like a can of Coca-Cola. Okay, that's what a right circular cylinder. That's the shape. All right, a can of Coca-Cola, any shape that's similar to that. That's what we're looking at here. And it says that the volume of that, which is the volume again, measures how much you can put inside of that object. Okay, so when they say that a can of Coca-Cola is 12 ounces, that is a measure of its volume. Okay. Anyway, that's not what the volume is here. I'm just saying, I'm just giving you a visual of what we're talking about here in general. Jointly proportional, what does that mean? That means varies jointly. Just like directly proportional means varies directly, jointly proportional means varies jointly. Let's go up to the top of the page here for just a moment. We need to talk about that. All right, varies jointly. See right here it says x varies jointly as a squared and b squared. They use the word jointly whenever they're talking about two things after the words varies jointly as. All right, instead of just one thing like we have in our previous examples here after the word as, we now have two things. And when they say varies jointly, it's the same thing as varies directly. Not varies inversely, but varies directly, where you multiply. It's just that you multiply by both of them, both the a squared and the b to the third after the k here. Okay, no division here. They didn't mention inversely here. Inversely is the time when you do the division. All right. And so let's talk about that here. It says here that the volume of a right circular cylinder, again, varies jointly or is jointly proportional to the square of the radius. Okay, what do they mean by that? Well, let's to make sure that we've got our that we can communicate this properly in math terms here. Let's come up with some variables for each one of these things. Okay, the volume, I'll call that V. Okay, naturally, right? Not that you have to call it V, but it's just easiest to call it the same letter, right? So the volume would be my V, okay? The radius will be R. Again, natural choice there. R for radius. And then it also mentions the height, okay? You don't need to do the circular base here because that's coming from the radius here, all right? It says the radius of the circular base, so that you can just call that radius for short. But it does say and to the height, so the height is a separate thing there. Okay. So those are my letters I'm going to use, my variables in this problem. All right, so let's try to write out a formula, because we can't put words inside of a formula, right? We got to have like numbers and variables and stuff, and so that's why I established this over here. All right. Now let's try to write the formula with those variables in it. Okay. Again, volume is, okay, jointly proportional and varies jointly. Remember, whatever comes before that phrase, that goes before the equal sign, just like in the previous problems. Okay, so I'll put the V before the equal sign. And then, again, varies jointly means that you take not just R and H, but remember, this is where you got to be careful. It says the square of the radius. So that would be, we put our K down first, but then it says varies jointly to the square of the radius. So that would be K times R squared, not just R, but R squared. Okay, if the word square hadn't been there, then you would just say K times R, all right, before doing the H. So we got to do the H part here. but it would just be k times r instead of k times r squared. But because of the square, that's different. And it says and to the height. Again, when you talk about jointly, you've got that word and up here, right here. And so it's telling you to take both of these things on each side of the word and to put them in there multiplied by the k like that. It's the same thing here. All right, they're saying varies jointly to r squared and the height. So r squared and h. And so we're going to multiply r squared and h, both of them, times the k, just like you see here. All right? And so that's why the formula comes out like that. Now, step 2. Again, we always want to figure out k in the second step, always. All right, how do we figure that out? Well, usually in the middle of the problem, they'll have a statement that says, it'll tell you what all of these other letters are equal to at the same time, just like it told me what all the other letters were equal to in this problem. It told me what y and x was, and so I plugged them both in at the same time, and it meant that k was the only variable left. It was the only letter left, and you could solve for it. All right, it's the same thing here. We have 3 other letters this time instead of just 2 like we did with y and x. This time we have 3 other letters, V, R, and H. And so if I plug in all 3 of the numbers that go together for V, R, and H, K will then be able to be solved for because it'll be the only letter left in your equation. See how they've got V is 300 right here? V is 300 when, meaning at the same time again, when the height is 10.62 and the radius is 3. So they're telling you that 300, 10.62, and 3. All 3 of those numbers there are all true all at the same time. And so you could plug them all in at the same time, and then K would then be the only letter left in your problem, and so you can then solve for it. Let me show you how it looks. V gets replaced by 300. Okay. The radius gets replaced by the 3, like that. And don't forget the square there because r squared. And then the height is 10.62. Okay, now remember what I said. When you plug a number into, or even in this case multiple numbers, when you plug a number or numbers into a term, simplify what it's equal to first, okay, before you try to solve the equation. Because the equation looks pretty weird right now, okay, with all this stuff here. We need to make it look like a normal term. Again, we do exponents before multiplication. So we have k times 9 times 10.62, right? All right. Well, how do you multiply 3 things together? You multiply them 2 at a time. 9 times k is 9k. And then 9k times this. What is 9 times 10.62? Your calculator will tell you that answer. That would be 95.58. 95.58. All right, your calculator again should tell you that. And so there you go, 95.58k. Because 9k times 10.62, you got to still bring down the k, right? Just like if you had 9k times 3, it would be 27k. The k is still there, right? So here's what we do. We got to solve that by what? By, let me just rewrite the equation here. We got to solve that by dividing both sides by the 95.58 so that the k would be by itself. Like that. And so we get what here? We get that right there. Do not, you guys, do not make that into a decimal if it's a decimal that covers your entire calculator screen, because then that means that they rounded it off normally. Okay, and if you put that in your calculator right now, if you haven't already, that will be equal to one of those long decimals that covers your entire screen on your calculator. In fact, I'll go ahead and show you that here. All right, 300 divided by 95.58, excuse me, There we go. And you can see it covers the entire screen here. That means they rounded it off here at the end of the screen. We don't ever want rounded off answers, you guys, before the final answer. Because if you have a rounded off answer and you're not even at the final answer yet, it will then make each step you do after that even less accurate than the current step would then be if you rounded it off. So don't ever round off before the final answer. Keep that. I know this is going to make it a little bit tougher, but you need to keep that intact as a fraction. All right, because you didn't round anything off. That's okay to keep it as a fraction. Now, the final answer you can round off because the problem says you can. It says you can find the volume to the nearest tenth. That means you can round off to the nearest tenth. But don't round off before that. And don't ever round off an answer unless it's one of those things where you're trying to graph a point on a graph. I've told you before you can round off then. But otherwise, don't round off until it's the final answer, and only if they tell you that it's okay. All right? Because otherwise they expect an exact answer. So we're going to do exactly the same thing that we normally do, all right, in the previous two problems. All right. We now know what K is, so we can plug that into the formula. It then says, hey, what is V? So I brought down the V. What is V when the R is 4 and the height is 15.92? Again, calculators are going to be very helpful here. What we do, like always, is we put at the end of the problem, we put our K in there. There it is. All right, as it's in fraction form like we talked about. Keep it that way. And then plug in the R that they gave you, which is 4. Don't forget that that's being squared right there. And then the H, plug that in. And then if you do the calculator work on this, again, do the exponents first. We got 16. Now, when you do the 16, we now have 16 over 1, and I make that into a fraction because we're going to multiply by this fraction here. Go ahead and make this into a fraction too. If you're multiplying a bunch of things and one of them's a fraction, it's easiest to just make them all into fractions. If you multiply the top and the bottom, the tops and the bottoms together, which is what you do when you're multiplying a bunch of fractions, you get 70, I'll just write it down over here, 76,416 divided by 95.58. If I then finally divide that to figure out that answer right there, okay, we get, and again, round off to the nearest tenth. If you see that in your calculator, it should say 799 point, and then it rounds up to, actually, I'm not sure if it rounds up or down. Let's go ahead and find out. Okay, so 76,416 divided by 95.58. And so yes, it's going to round up to 5 there, all right, because the next digit is bigger than 5, so the 4 rounds up. And so 799.5. Now, as I mentioned back in section 3.1, you guys, when we did some word problems there, okay, if your problem mentions measurement, such as centimeters or cubic centimeters yeah, that's pretty much all we have is centimeters and cubic centimeters. Anytime they mention any kind of measurement like that, that means your answer is also going to be going to need to have measurement as well. So since we just found the volume, you just need to figure out how they measure volume in this problem. Well, according to this statement up here, it says a volume is 300 cubic centimeters. They're telling us that cubic centimeters is the way in which they measure volume in this problem. Okay, so this therefore must also be measured in cubic centimeters. All right. So 799.5 cubic centimeters is the volume of this particular right circular cylinder that they're talking about. Okay. Okay, let's go ahead and flip it over to the other side now. There's one more problem back there. And this one involves something we haven't talked about yet, but it's a combination of a few things that we have talked about. Let's go ahead and take a look at that. If you see on the front side of the worksheet, we have this last one here, this last example. It says y varies directly and also inversely. All right, it varies directly as x squared and inversely as z. All right, so look at what happens when it has both of those. As you know from the top here, directly is a reference to multiplication. Inversely, on the other hand, is a reference to division, okay, as we've already talked about. So when you have both, then it's still the same thing. See how they multiply by x squared over here because directly refers to multiplication. So directly as x squared means multiplied by x squared. Inversely as z, again, since inversely is division, then that's why they divide by z. Okay, so directly as x squared is multiplied by the k. Inversely is z, and then that means you're dividing by z. All right, so let's keep that in mind here because we're going to have a similar setup here in problem number 4. Let's read the problem. It says a measure of malnutrition called the pelodicee varies directly as the cube root of a person's weight in grams and inversely as a person's sitting height in centimeters. Okay, let's go ahead and stop right there before we finish reading that. Again, let's establish some variables here just to make it possible to set up the formula. Let's call P will be the pelodicee. That is, again, the measure of malnutrition. We'll talk more about when we can get through the problem here. Finish reading the problem, what that means, what the numbers mean for the pelodicee. It talks about it. But it says the cube root of a person's weight. So weight is another thing. Okay, and then it says inversely is the person's sitting height. And so I'll just say height for short here, but the person's sitting height is another thing. Okay, so those three things right there we're looking at. Let's keep going here. A person with a pelodicee below 100 is considered undernourished. A person greater than 100 for the pelodicee is overfeeding themselves. A person who weighs 48,820 grams with a sitting height of 78.7 centimeters has a pelodicee of exactly 100. So that person is like right on the money as far as the correct nutrition. Okay, because if you're over 100, that's too much. If you're under 100, that's not enough nutrition. Find the pelodicee to the nearest whole number of a person whose weight is 54,430 and whose sitting height is 88.9. And then we'll answer this last question based off of that. So, as always, step 1 is to establish the formula. How do I know that that's the case here? It's because I know that this is a variation problem due to the fact that they mention varies directly right here. So this is a variation problem. Okay, so it says what? It says varies directly as the cube root of a person's weight. So we want to take the cube root of W, right? All right, but even before that, remember the pelodicee is what varies directly. Remember, whatever it says before they say varies directly, that is the thing that goes before the equal sign, right? Just like when they said y varies directly, that means that y, because it goes before, varies directly. That means that it goes before the equal sign. Then it says it varies directly as the cube root of a person's weight. And so that means that we're going to say k, and then varies directly means times the cube root of the weight, the cube root of w. But it says and inversely as the height. And so that means, just like we saw on the front of the worksheet just a moment ago, it means we're going to divide by h at the same time. Okay? So multiply by the cube root of w because that varies directly. Divide by h because that varies inversely. All right? Okay, now, step 2. Step 2 says what? As always, it means that's the step where you got to find the k number, right? Just like in the previous 3 problems. Again, this means that we look for the statement in the problem where it tells us what all of the variables are equal to except for k, so that we can then plug them all into the formula, and then k will be the only variable left we can then solve for it. Okay, here is that particular statement right here. See how it says right here that The weight is, in other words, the W is 48,820 at the same time that the height is 78.7 and the Pellet or the P number is 100. So it's saying that those three numbers all go together because it's the same person, all right, who has all three of these characteristics, the weight, the height, and the Pellet number. All right, same person, therefore they all go together, and so therefore you can plug all three of those numbers into the formula at the same time, and that's a perfectly true, accurate thing to do. All right, it makes the equation true. So let's do that right now, and you'll see that K will be the only thing left that's a variable. So we get 100 is equal to K times the cube root of, and what is the weight? 48,820, okay. And underneath that is what? The height, because the H is underneath right there. And so that's where we put the 78.7. Okay, now how do we solve that? How do we solve for K? Once again, when you have a fraction on one side and then just a normal number like 100 on the other, you can cross multiply after making this into a fraction over here. If I do that, I get 100 times 78.7 is 7870. Again, have your calculators handy here. And then 1 times anything is itself, so the other side will just be the K and the radical right there. I then need to divide by the radical in order to get the K by itself here. This is just a normal linear equation because it's just K to the first power. It's just K times a constant number, and the radical is a constant because there's no variable in it, and then a constant over here. So it's no different than having like 12 equal to K times 3. It's the same thing. It's just much more complicated looking, but it's the same idea. A constant equal to K times a constant. You divide out this constant over here, and it gets the K by itself. Now here's the thing though, just like we saw in the last problem, if you put this in your calculator right now, all right, it's going to give you another one of those nasty decimals. It covers your whole screen, which means that the calculator rounded it off. So what I need you to do then is just keep this fraction as it is. Don't try to make it into a rounded off decimal. We're not allowed to round off before the final answer like we talked about. Now in this problem, we can round off the final answer itself because it told us we could round to the nearest whole number. All right, so we'll get to that here in just a moment. But first of all, like always, after we figure out what the K is, we then plug it into the formula, and then we answer the question. It says find P for when the weight is 54,430 and the height is 88.9. So we plug in those two numbers into W and H, weight and height, and then we also plug in the K number that we have. It's going to look pretty weird, pretty complicated, but we'll get through it here. So the K goes here. Okay. Again, I'm just going into this formula here. All right. So there's the K. And that gets multiplied by the cube root of W, and the W that they're referring to here that they want to answer the question for is the 54,430. Again, that's part of the question here, is that number here. When that number gets plugged in and when 88.9 gets plugged in, all right, what is all of this stuff here? All right, now, the best way to solve this, okay, is to figure, again, with any fraction, and this ultimately is one big fraction here, with the big fraction bar. So figure out what the top is equal to first. Okay, and we can do that by putting this over 1 right here and just multiplying that through. All right. So we're going to multiply by we're going to multiply the numerators together here. We get 7870 times the cube root. Here's how you do the cube root. You put the 3 in there first, then you hit this button right here. And again, if you don't have the same exact calculator, you should have something similar to this if you have a scientific calculator like we talked about. it has a radical, but then it has this little variable where the cube root or the fourth root would normally go there. I know it's hard to see on the screen here, but it's there where the index number would normally go. Okay, for the cube root of the fourth root. Okay. But you got to put that 3 there to tell the calculator that it's a cube root and not a fourth root or fifth root or something like that. So I hit that button, and since it's above the button, I have to activate it by hitting the second key up here, like that, and then that activates it. And then we put 54,430 in there. Okay. And that gives me what the numerator is equal to right there. So then we have to divide it by what the denominator is equal to, which is the cube root times 1, which of course is just equal to the cube root since it's multiplying by 1. And so I'm going to say this. I'm going to say divided by the cube root. So again, we have to say 3 first, and then that same button again, and then we put in what? 48,820. Like that. Now that gives me what the entire numerator is equal to. This whole thing up here, it tells me what that's equal to. And so now I need to take that and divide that by 88.9, which is on the bottom right there. All right. And that gives me final answer here, 91.7, and so on after that. Remember it said to round off to the nearest whole number. That means to round off to this place right here, the last place on the left before the decimal point. That's the nearest whole number. So since the 7 is bigger than 5, we're going to round up to 92. 92 is my final answer rounded off to the nearest whole number. Okay. And the thing about the Pelodisi, I know I said earlier that when your problem has measurement in it, such as grams and centimeters and whatnot, that your answer should as well. But this is the one exception, all right? The reason why you don't have anything in here like 92 feet or 92 yards or something like that is because that's just not how the Pelodisi works. It's meant to be just a number that tells you whether or not you're underfed or overfed. But normally, as in the last problem with volume, because the last problem it talked about how volume was measured in cubic centimeters. All right, that's why we said cubic centimeters on our answer in number 3. But here, because the Pelodisi doesn't have that, that's different. But usually, you need to look for how the final answer is measured when you have a problem such as most word problems that have measurement in it, such as grams or centimeters or things like that. Okay, so just wanted to let you know that. So yeah, it'll just be 92. Now, what is the last thing we need to do here? Is the individual undernourished or overfed? We got to answer that. Because it says up here that below 100 is considered undernourished, all right, that must mean they are undernourished, all right? All because, again, because of this right here, all right, where it says below 100 is considered to be undernourished. And, of course, the number ended up being 92, so there you go. Undernourished it is. All right. So one other thing I want to point out, you guys, and I can't go over every single different possible calculator and how you enter things, but just to let you know, when it's a simple one-line calculator like this, usually how you would enter a cube root is you do it the opposite way. Instead of entering the 3 first and then a number underneath the radical, you'd go the opposite way. For example, let's say we were doing cube root of 8. Okay, what you do is you would actually do the 8 first, the number underneath the radical first. Then you activate that button that is the cube root right there, the same one as I was showing you earlier, where it has the little variable where the cube root would normally go. Activate that, and then put in the type of root you're doing. So if you're doing cube root, you'd do 3 after you hit that button instead of before, and then you hit the equal sign. Let me zoom out. All right, and I hit the equal sign, and you can see it gives me the correct answer. Cube root of 8 is equal to 2. So you do this problem, in other words, the same way that we did it with the other calculator. It's just that you would enter the 5, 4, 430 number first, then you hit the button with the radical on it, and then you hit the 3 after that. You do it. You do those numbers in the opposite way. It should still give you the same answer here. Again, I know everybody's got a different calculator, so don't hesitate to let me know if you have if you're not getting the answers that you expect to get with your calculator. I'm sure we could figure it out. And if you have any questions about anything else, not only in this section, but also in Chapter 3, please don't hesitate to ask. All right. And in the meantime, I hope you have a good day. Take care.